Morning.
Morning.
Hope you're already awake. glad you made it through the traffic jam and registration. So, not sure if any of you saw the Apollo Lego rocket in the expo on the way here. So we're also going to talk about something space-related that happened a little later than the Apollo program and how JSR 385 could have avoided that incident. The Mars Climate Orbiter was launched in December 1998. Here are a few stats. It was supposed to help NASA study the climate on Mars and potentially also if people could live there someday or if there may even be life on Mars, even if it's only microbes. The result, however, was that you see the planned trajectory was supposed to be almost 200 kilometers more than what it actually did. And because it was so close to Mars, even though the gravity on Mars is a little smaller than on Earth, it still sucked the vessel into the atmosphere and it disintegrated and probably the remains crashed on Mars. So why did this happen? Well, there are several subcontractors involved, and while NASA, we also heard from an engineer who had already worked on the Apollo program last week in Milan, that NASA is actually quite good at that, and they used metric units even inside the software and the components of the Apollo mission. But because there are more and more other companies involved, not just at ESA here in Europe, of course, where you have sometimes 10 different companies from 10 different countries assemble such systems. In this case, there were at least 2 involved, and Lockheed Martin used the US Imperial units while NASA relied on the metric units, and that caused a miscalculation which essentially made the satellite crash and NASA lost over $125 million. Here are the official statements by the NASA administrator. So what are the lessons learned? First of all, read the specs.
Always right.
And when you use Java, of course, that goes pretty much the same for other languages. There are similar libraries and frameworks, some of them, one in JavaScript for Node.js or Angular is even called MCO after the Mars Climate Orbiter, and it was it mentioned the first version of our JSR 363, and there was even an effort a little earlier that it's many years ago when the JCP did not quite feel ready for that kind of technology because simply the IoT was not trending as much as it does now. So this is already the third approach, and now it's the second version of this third approach. Yeah, and you ideally fail fast. In many cases, the JSR helps by failing ultimately at the compiler level already. So there are certain things that you can't even compile the code unless you do them right. There are, of course, a few other unit mishaps.
Quite a few.
America would not have been found, probably, if it wasn't for a miscalculation by Christopher Columbus, who thought he would be in India, and he actually ended up in the Caribbean. There's an Air Canada flight, famously known as the Gimli glider, that went out of fuel because Canada had just entered the metric system, and some systems of the fuel chain had still not been adjusted to that either. So it ran out of fuel, and it had to do an emergency landing without fuel. There was a turtle in one Californian zoo that was lent to another one, and the zookeeper of one zoo and the zookeeper of the other had a phone call, and they also talked about, how big is it and what does it weigh? And they mentioned a figure, but it actually turned out that one person was thinking in pounds and the other was thinking kilogram, and that made the tortoise wreck the wall. So it's not the only wall in California that doesn't seem stable enough, and in this case, it was not some people from Latin America, but actually the giant turtle that wrecked the wall and escaped. And of course, there were a few other, sometimes pretty tragic and fatal mishaps where the dosage of a medicine was misplaced by using the wrong unit, which in some cases even led to the patients dying. So what are the fundamental problems? Primitive types are, as the name says, primitive. They're mostly supposed to build other complex types. So for example, you may have something like this, and it doesn't really say what unit it is, or other than the name C, you don't really get much semantic out of it. If you call it differently, then you may already know a little bit about it. That in this case, it would be the speed of light. If you go even further with the naming convention, then you actually get closer to a meaning. But of course, it would be nice if you could do something like this, which we'll show you soon how to do in Java. Or you could create your own library and framework. Has any of you ever done that in a project, either in Java or a different language? No?
One.
Okay.
I saw
one. Yeah, if you do this, and we also have in a similar smaller case, for example, one colleague of mine decided to create his own stopwatch, even though I later found out that, there's an Apache framework for it. So why not use an established open source project? Because you have to develop it, you have to maintain it, you also have to document it, of course, in Java. You should write Javadoc for it. And you need upgrades and improvements or fixes. So all in all, it may not be a good idea to do this. So who are we?
Who are you, Werner?
Yeah, I'm one of the spec leads, or actually maintenance leads of JSR 385.
Hi, Thodoris Bais, member of the expert group of JSR 385. Welcome all. Good morning. Thank you for joining us.
So what is JSR 385? So this is the description from the JCP page. It's a major upgrade of JSR 363, which was the first version. Of course, the metric system has also been redefined, although most of it was done more or less on a formula level, but that also required a lot of changes, especially when it comes to the documentation. This was the first description of JSR 363 at the JCP page. So some of the basic concepts. We have dimensions, we have units, quantities, prefixes, which is actually something that's new with version 2, converters, and formatters and parsers for input and output. And last but not least, a system of unit definition that allows you to define your own system of units or reuse some that are already there for the most basic cases like the metric system, US customary, and a few others. What are quantities? Here's a Wikipedia quote, and here another one. For us, essentially, a quantity holds together a numeric value and a unit. And the same quantity can be interpreted in different unit systems. So for example, meter per second or kilometers per hour. Again, here's the speed of light. Or if you convert it to kilometers per hour. The units, as mentioned, they have already been redefined. So this is the new graphic design by the metric system that was introduced on May 20th when the redefinition went into effect. That had been decided in the metric convention approximately 1 year ago. I think it was on the 18th of November, so it was almost 1 year ago. And unlike some other, well, don't even need to mention things like the Brexit, but in this case, there were only 2 countries, I believe, that were absent, that couldn't make it. But other than that, this was unanimously approved. So it's, with all the misunderstandings and different opinions, in this particular case, luckily, the whole world agreed and unanimously approved it. Luckily. And here we also got derived units that are based on the base units. There are multiples, like kilometer, millisecond. You could also have things like megameter, although it may not always be so common. But there are other numbering systems, especially in India, where lakh and crore that you can also use with some of the extended unit system modules. And there it's sometimes quite common, especially with large distances, to also refer to lakh meters or crore meters. So the dimensions are the basic dimensions of the metric system: length, time, mass, electric current, thermodynamic temperature, amount of substance, and luminous intensity. We also got a constant 1 that can be used for dimensionless quantities. So for example, here, how force is made up. So it's a dimension that is made up from different dimensions. Here we get all the base quantities again with the units and the corresponding dimensions. Okay, how about a little bit of math?
I'm tired.
It's early.
8:15, right? Welcome. Good morning.
Mhm.
So, JSR 385, right? Units of measurement API. Shall we do a bit of math today? I would say let's go for it, right? So let me actually start with equality and equivalence, right? And of course, I will begin with units. So quickly going through this short list that I have prepared for today. A kilo and a millihertz are always different. Same applies to a kilo and a milliohm. Those ones are always different as well. What about a kilo and a kilo? Those ones are equal, right? What about Newton compared to kilograms meters per square second? Those ones are equivalent, right? And once again, kilograms per square meter is equivalent to milligrams per square millimeter, right? Pause. Kilograms per square meter equals to milligrams, yes, per square millimeter. So here comes my question. Should you maybe use functions to normalize expressions into what could be considered closer to the base unit? This is something you should consider, right? And let me quickly walk you through the quantities as well, just to show the related example. So here again, on the very last one, right? 1 kilogram per square meter is equal to 1 milligram per square millimeter. Could you use a function to normalize the milligram per square millimeter into its base unit, which is kilogram per square meter? It depends on your case and on the particular scenario you are investigating, right? For example, there might be, on the other hand, a very rare case where you would need to use the milligram per square millimeter. For example, some paint for a very small device, right? You might need to use the milligram per square millimeter. Of course, all over again, 1 kilom is different to 1 millihertz, 1 kilom is different to 1 milliohm, 1 kilom and 1 kilom are equal, and 1 Newton is equivalent to 1 kilogram per square meter. Okay, however, what happens here? What happens here? 1 kilo is equivalent to 1000 ohms. So as you can see, it's not only about comparing the values and the units, but it's also about converting to one base unit and doing the comparison in one reference unit. Equality and equivalence, some very basic rules we should always keep in mind, right? Good morning. Let me touch a bit upon quantity addition. What am I going to do right now? Something very simple as well. First of all, I'm going to show you a few examples, and then I'm going to explain the theory behind it, right? So let's go step by step here. 1 ohm plus 1 ohm equals what else? 2 ohms, right? 1 ohm plus 1 milliohm equals 1.001 ohms, right? 1 milliohm plus 1 ohm equals 1000 to 1 milliohms. What about 1 ohm plus 1 meter? That should never compute, right? That's why also in our unit API JSR, we are throwing an incommensurable exception, if I can remember.
Actually, this one would not
correctly.
even
compile,
compile
actually.
in the
That
first
one
place,
would
yes.
never
Mhm.
compile, yes. So what is the theory behind that? First of all, we say we're going to use the base unit if we can. If we cannot use that and it leads to an overflow error, we fall back to the second unit. Otherwise, if both units lead to an overflow error, we just throw that error, right? So we just throw an overflow error. Okay, so we talked about equality and equivalence and quantity addition, some very basic concepts of our JSR. However, it's a Thursday morning, right? And we're talking about units of measurement, API. Units of measurement, if I hear it in a different session, I would think like, hey, we're talking about maths, right? So what's better than having a quiz today, right? So how much is 0 degrees Celsius plus 0 degrees Celsius? And of course, that's quite straightforward, I would think, right? Good one. You might win something later on. You never know, right? I'll keep it in mind. However, if I would be sitting back there with the boys, I would be thinking, hey, why is this dude asking us that quite easy question on a Thursday morning here at JFL, right? There must be something behind that. So let me show you all the available or the possible answers. First of all, is it 0 degrees Celsius? Is it maybe 0 degrees Celsius? Or, as my friend said here in the first row, 273.15 degrees Celsius. How many of you think it is 0 degrees Celsius? 1, 2. Oh, okay. Now we started. Now we are awake, I guess. Hi. How many of you think it's the second 0 degrees Celsius? And how many of you think it is 273.15? I see a hand there. Yes? Okay, cool. Well, guess what? All answers are correct. And why is that? Let's see that for ourselves, or let me just explain and walk you through. First case, for the 273.15 degrees Celsius, right? What are we gonna do right now? First of all, when we're talking about, or let me first examine the case where we are talking about two absolute temperatures. Remember the SI system? Remember the physics that we've been doing at school back then? So for an absolute temperature, 0 degrees Celsius means 273.15 Kelvin, right? So the sum of 2 times 0 degrees Celsius for this particular case means actually 2 times 273.15 Kelvin, right? Which is, of course, 546.30 Kelvin. And which in turn gives us 273.15 degrees Celsius, right? So that was case 1, 2 absolute temperatures. Let's go to the second case, right? So 1 absolute temperature and 1 temperature change. What did we say for the first case? For an absolute temperature, 0 degrees Celsius means 273.15 Kelvin. However, when we are talking about a temperature change, 0 degrees Celsius means 0 Kelvin, right? So the sum of 2 times 0 degrees Celsius for this particular case would be nothing else than, of course, 273.15 Kelvin, which in turn gives us 0 degrees Celsius. Short recap. First case, 2 absolute temperatures, right? Second case, 1 absolute temperature and 1 temperature change. And what is left for the third case? 2 temperature changes, right? What happens here? So, for a temperature change, remember what we said for the second case? For a temperature change, 0 degrees Celsius means 0 Kelvin. So here, of course, we have nothing else than 2 times 0 Kelvin, which is, of course, 0 degrees Celsius. That's why we said all the 3 answers are correct. And as you might have probably made clear, it always depends on whether we are talking about an absolute temperature or a temperature change. And you know, these 2 cases we hadn't modeled initially, and we ran into quite some trouble while developing JSR 385. So here comes my question. Do you think you're an expert in your own system? Do you think you know the SI system that well to create a library to deal with all these kind of SI peculiarities? And if you cannot answer that question for yourself, I can answer it at least for myself. So when I very first got exposed to the JSR 385, I couldn't even imagine that thing. But of course, sometime ago, I got to realize that there are a few peculiarities in the SI system which you need to take care of. On the other side, on the other hand, of course, use JSR 385, which provides everything out of the box to you so that you don't even have to care about the SI system peculiarities. We'll show you later on how easy it is to use it out of the box and never try to figure out what's going to happen with the differences between Kelvin, Celsius, and all this kind of stuff. So, however, one more point, which I would like to park, so I would just like to mention it for now. Degrees Celsius is not a good unit to measure temperature. We examined 3 different cases using degrees Celsius, right? And you saw 3 different cases, 3 different answers. Of course, it provides you with a good scale from 0 to 100 degrees, but it's not a good one. I'll come back to that one later on. So let me quickly walk you through multiplication, which is more or less what you are already aware of up until today. Kilogram times meters equals kilogram meters, right? Kilogram times millimeters equals kilogram millimeters. What about gram times kilometers? That one equals to gram kilometers. Should you leave it as such, or should you better convert it to kilogram meters? That's something you should give a thought, right? It always depends on your case, as I mentioned earlier. Meters times meters equals square meters. Kilometers times kilometers equals square kilometers. What about millimeters times kilometers? That one, of course, equals millimeter kilometers. Should you leave it as such, or should you better convert it to square meters? It depends on your case, once again. Micrometers times meters equals micrometers meters. Should you leave it as such, or should you better convert it to square millimeters? Again, it depends on your case. Quantities, however, are quite straightforward. You just multiply the value and the unit, but please do keep an eye on the quantity. Please do keep an eye on the way you're going to express the quantity, because it might have a few strange effects, as you can see here, with the middle dots and the times. Of course, a few words about division, right? What about units division? Kilogram divided by meters equals kilogram per meters. Kilogram divided by millimeters equals kilogram per millimeters. Gram divided by millimeters equals gram per millimeters. Should you leave it as such, or should you better convert it to kilograms per meters? Depends on the case, right? What about square meter divided by meters? That one, of course, equals meters. Meters divided by meters equals 1. Kilometers divided by kilometers equals 1 as well. What about this one? Kilometers divided by meters equals kilometers per meters, which is equal to 1 kilo? Of course not, right? JSR 385, please use it. Quantities, however, are quite straightforward as well. Please do keep an eye on the way you're gonna express the quantity itself. Powers. So we talked about multiplication regarding the equations and all this kind of stuff. Division. So now let's touch a bit upon powers. For the units, the square of a meter equals square meters. The square of kilometer equals square kilometers. What about the square of square meters? That one equals meters to the 4th power, right? Quantities, quite straightforward. Once again, you know what you need to pay attention to. And of course, I told you I would come back to revisit Celsius. Let's start once again with a couple of examples. And then I will explain why it's not a good unit to measure temperature. The square of Kelvin equals, of course, square Kelvin, right? What about the square of degree Celsius? What the F is that? Is that equal to K minus 273.15 to the second power? Of course not, right? What about meters times degree Celsius? Is that equal to meter times Kelvin minus 273.15? No. No, but I need to also mention a rare case. There is a very specific case where you might want and need as well to use that unit, that quantity, meters times degrees Celsius. For example, when we are talking about an isolation material, we could say isolation material X can hold up to 5 degrees Celsius per meter, right? But that is only one very specific case. However, of course, degree Celsius is not a good unit to measure temperature. And about quantities, what is the square of degrees Celsius, of 0 degrees Celsius? Is that 74.610? I don't even want to pronounce that, right? You shouldn't really use degrees Celsius for measuring temperature. Next one more rare case. 1 millicelsius. Is that equal to 1 millikelvin or 273.151 Kelvin? Well, of course, the answer is 1 millikelvin. And you're going to ask me why? And I'm going to answer, I don't know. Of course, I don't know because behind that, there is something very specific on the SI system. Remember what I mentioned earlier? The SI system has quite a few peculiarities. So that's why I cannot explain this answer. Now, let's talk a bit about parsing units and quantities, right? And of course, the example Werner used earlier with the speed of light. You have many Unicode characters or many keyboard characters you could use to parse units and quantities. Is it visible all the way back there? Yeah? Cool. Of course, you can use decimal point, no decimal point, thousand separator, the slash for kilometers per second, the times, as you can see. Sorry, that is the star. The times is here. And what do you see here? For expressing a superscript, you can either use, that's why we have two different cases, you can either use the superscript, the HTML sub element to express your superscript, or the Unicode -1 superscript element. And of course, a few more cases with the middle dot, the caret, kilometers per hour once again. And what is this one? What is this one? Kilometers per T? What is T? It's not the initial of my name. T is a local representation for time. And you need to keep an eye on that. Because if you try to parse that kind of quantity in your own locale, for example, if we would be living in Norway, right? And if we tried parsing kilometers per T, could you even imagine what would that mean? That would mean that it would have been parsed as kilometers per tone. It's crazy, eh? Please use JSR 385. Yes, and miles per hour, no middle dot, no nothing. That was it about parsing units and quantities. JSR 385 provides many different ways to parse, either from the command line, from a file, from as an argument. It always depends on your case and your taste. So, systems of units. What do we have? Of course, we have quite a few systems of units, right? It depends on your location and your taste, once again. So, we do have the metric system, which is our known units, which has our known units, so meters, kilograms, ampere, seconds, and so on and so forth. We do have the imperial systems of unit, which is derived from the English, right? And yes, I know you don't like it, but we also have the US customary units. And those two US customary units and the imperial units are more or less the same. However, in US, they use one specific unit to measure or to represent two different units as known in the imperial system. So to make it more simple, in the US, they use gallons to represent both gallons and horsepower. That's why you should please keep an eye on your own systems of unit. What else? Of course, for the traditional ones of the room, you do have the Roman units of measurement and some local representation like Norwegian, or depends on the country you are, right? So, Werner, shall we show a demo actually? Let me see how I can get that working. So, visible? Okay, so Werner, what are we gonna see here?
How's the font size in the back?
I'm gonna fix it.
Okay.
What do we have here?
So Thodoris just brushed the case that parsing could lead to something like kilometer per ton. Now here we talk about something that's slightly the other way around. It's basically how many kilograms or tons of carbon dioxide are produced when you travel a particular distance, depending on the vehicle they use.
So let me run that as well.
So let's run that for
the Porsche example. And what do we see here?
So here we have a particular distance like 600 kilometers using a Porsche Cayenne. The 14 liter per 100 kilometers is the average fuel consumption. There are also certain differences, especially if you're only driving in a city, it may be higher. If you're driving at a constant speed, then it's usually not that high. And this is usually a mix of both. Then it shows that per kilometer, 333 grams of carbon dioxide are produced by that vehicle. So if the Porsche driver rides 623 kilometers, then this produces over 200 kilograms of carbon dioxide. We had to do a little bit of tweak, basically because strictly following the physical formulas and model, the whole calculation would actually go down to liters, I believe. That's why we had to take the last number out and explicitly create a mass, which you see in the very bottom. So that's why there's a wild card with the carbon total. If you use that carbon total without any magic, then you could end up with liter, simply because the whole calculation in the first place was started with how many liters does the vehicle consume in fuel. And because there's some strange magical factor that you also see down there, that's some factor for the carbon dioxide consumption, which is simply a number. It doesn't really have any particular dimension. And because that number would only be seen as a number and no quantity change would happen. That's why we have to take that number in a known state and put it into a new mass quantity ourselves. Otherwise, it would be interpreted as liters, which we don't want in this case. But as soon as we converted it into a mass, we can then do the conversion and simply say, okay, we want to see it in kilogram, or in the US, you could also do it in pounds. Okay, let's try another example with a slightly more efficient vehicle.
Yes. You want an Italian one? Let's go for a Fiat 500, right? So what would happen here for a Fiat 500?
Yeah, so as you can see here, and we didn't even use the other, even more wasty Italian vehicle by the same group, which would be the Ferrari. But even if you just compare the Porsche, which is quite common in this part of Europe, especially in Germany, and compare it to a Fiat, the Fiat produces approximately 1/3 of the carbon dioxide footprint compared to a Porsche. I think with the Ferrari it would be even 1/4 or 1/5.
Definitely.
Yeah. You'll find all of this in our GitHub repo. There are also some other examples that show the differences between the temperature in absolute and relative. So what Thodoris explained earlier with the Celsius problem led to a new addition to the API, where the quantity now has an additional enum called absolute or relative. By default, usually it's assumed to be absolute, but for certain special cases, especially with regards to the temperature change, or when you deal with measuring the energy efficiency of a building or of a heater system, then you might want to use relative temperatures. And then, for example, the temperature difference would always be Kelvin, as we saw in the math example.
Definitely. And as Werner mentioned, we're going to share all the examples later on via Twitter. You can follow us there. You can see it. Also the presentation as well. There are quite a few examples. However, before wrapping it up for today, let me just do a short recap on the question of Werner from the very beginning. What was the fundamental problem once again, right? So Java primitive Java types are just primitive types. What is the reason Java is in a parenthesis here? Because that one applies to any single kind of a programming language. So in the parentheses, you could also have C++. Primitive types are just primitive types, right? So they're not good enough to represent quantities. That's why you should use JSR 385. And it's quite simple, actually. All you need to do is to just import the INRIA dependency, which is the dependency for our reference implementation, in your POM file. Quite simple, right? And everything comes out of the box for you. You don't really need to manually convert kilometers per hour to meters per second anymore. Our library does all the dirty work for you. What did I say? Like that, right? Quite simple. You just import the INRIA dependency and everything comes out of the box. We'll share.
There's a 2.01 patch, by the way, but just use the latest version if possible.
Yes. So we'll share everything later on. However, what is the current status of our JSR, right? We just went final a few weeks or months ago with the version 2.0. You can find more in our JCP page and the GitHub repositories. We'll share them later on as well. And of course, speaking of JSR 385, I would also like to give a final thought on the Java community process. How many of you know what the Java community process is? 1, 2, 3, 4, 5. Oh, that's good.
Okay.
That's good for a Thursday
Oh.
morning.
It's good for first one.
Yeah, right?
Of course, not so surprising for a Java conference.
Yeah. That's
Remember
cool.
Milan? I think there was one person only.
One person, yeah. That's why I'm surprised. So it's really cool. Why I would like to touch upon the Java community process? Because it is a platform where you can get exposure from, and of course, you also help by investing your own time in order to contribute to the future of Java, right? So it's a win-win situation. I would say you invest your own time, you volunteer, and you get something back. Your name will be mentioned, or you might meet someone helpful to you. And I would like to take myself as an example. 1 year ago, I just started contributing as improving, in the sense of just improving the documentation. We then helped in running and adopted JSR within our Utrecht JUG, and today I'm here representing the JSR itself. So do give it a thought, and if you want more information, please come find us later on. And speaking, of course, of the JCP, we are running for an associate seat. So, as of November, we have the executive committee elections in the JCP. Each associate member has the right to cast 2 votes. So please, do vote for Werner Keil if you think we can contribute more to the future of Java. Werner has been an associate member and a member of the executive committee for the last 9 years. And he's doing great stuff, I can tell you. And of course, for our very own Utrecht Java user group. We've done quite some things this year, and we're really passionate about contributing to the future of Java. So if you are an associate member of the JCP, you have the right to cast 2 votes in the executive committee elections. How to become a JCP member? We can tell you later, because I see we're running out of time. It's quite simple. For now.
But by the way, the JSR as such, and also the 3 spec leads, also just won a JCP award for the best JSR of the year. And for the sake of budget saving, they combined 2 different award categories. So we won a combined spec lead and JSR award. In 363, the JSR won the separate JSR of the year award, and this time we basically won 2 awards which were combined into one.
So you know what to do. Thanks a lot. Do we have time for questions? No. Do we? Any questions? If not, first of all, are there any? If not, we'll be around for a few hours.
We're around, and otherwise you can ask question always
on Twitter.
On Twitter or on the mailing list. There's also a Google group for both developers and users of the unit framework. So depending on whether it's an end user question or a question about the framework itself, please also ask questions either on GitHub or on Google Groups.
Thanks a lot for your time.